Angle is two rays connected at an endpoint, and that endpoint is called the vertex. And so it's the point, the vertex is the point at which the sides of the angle intersect. Okay, a protractor. Semicircular instrument. Semicircle, it literally means half circle. So half circular instrument, typically made out of plastic or metal, that is used for measuring and constructing angles. And the reason it's a half circle is a full circle is 360 degrees, but we only measure angles between 0 and 180, because as you go around you can get angles bigger than that, but then it becomes confusing and you have to worry about direction, because are you measuring the big angle that goes all the way around the outside, or are you measuring the little angle on the inside? So the standard is just to measure between 0 and 180, just to avoid confusion. An acute angle is any angle less than 90 degrees. And you can remember that because they're cute, they're little. A right angle is exactly 90 degrees. And then an obtuse angle is any angle that's more than 90 but that's less than 180. 180 degrees is called a straight angle because it makes a straight line. We don't measure angles with negative numbers. So it doesn't matter what direction the angle is facing, we're always able to measure it so that it gives us a positive answer. So, and that's what the protractor postulate is that the protractor is numbered in such a way as that we can always get a positive number for our angle, and it'll always be between 0 and 180. And that's why we have the two rows of numbers going in opposite directions of each other. And we talked about that an angle is made up of two rays. This is ray BA, the blue. And the purple is ray BC. And B is our vertex. Now this angle can have more than one name. We call it angle ABC. It's really important what order you put the letters in. The center letter is always going to be the vertex. Because if I called this angle BAC, it would be an angle that went like that. Okay? Because A would have to be the vertex. So just be really careful. Oops. Your middle letter is always your vertex. Now, because this angle is not attached to any other angle, and B is only the vertex of this one angle, I could call this one angle B. If there was another line coming off of it like this, though, then I couldn't call it angle B because I wouldn't know which two angles I was talking about. So you can only call it by the letter of the vertex if it's by itself. You can also give the angle a number, like that, if you want to, and you can call it angle 1. And that's convenient because if there is another angle like this, right, I could call this angle 1 and I could call this angle 2, and then I would know which one I was talking about. Or if this was D, this would also be CBD, or angle 2. But I couldn't call either of these angles angle B because there's two angles on there. So you can either number the angle, call it by the 3 letters, or if it's alone, you can call it by the letter of its vertex. Okay. Our right angle. This box indicates 90 degrees. So this is our right angle. Okay. Anything less than 90 degrees is an acute angle. Anything greater than 90 but less than 180 is an obtuse angle. The reason we have 2 rows of numbers, if our angle opens up to the right, like this, that's when we're going to use these inside row of numbers to measure it. Yes.
Can you say that over again?
Yeah, if the angle opens to the right, so if it opens pointing this direction, that's when we use the inside row. If it opens pointing the other direction, that's when you're going to use that outside row of numbers. Okay, and the reason we do that is, I'll be showing you how to use the protractor, but if I look at this angle, and if I extend it all the way out, it hits both. I mean, this is not accurate because it's not drawn in the right spot, but let's say it hits 60 and 120. This is not a 120-degree angle, right? It's less than 90. So that's why we're using the inside row. Whereas out here, if this angle hit like 30 and 150, it wouldn't be 150, it'd be 30. So it's just that the two rows of numbers are there to make it easier for you, so you don't have to worry about trying to like flip the paper over or flip the protractor a weird way. You know, it's to make it easier. So we have the hole, right? The hole in the protractor goes right on the vertex. So the dot of your vertex or the corner of your angle goes in that hole, and then the black line that comes out of the hole is where the bottom ray of the angle, you want to line it up with that. Okay. And then the other ray of the angle will hit one of these numbers. So as we look across here, it's hitting 60 and 120. We already discussed this. That's not an obtuse angle. So we're going to use the inside number of 60. So this angle would be 60 degrees. Okay. Now if your angle is too small, let's say your protractor is like this big, right? And your angle comes like that. That happens. You just take your protractor again and use it as a ruler and extend your angle far out to where it'll touch the numbers for you. You don't have to really do that with the bottom one, it doesn't matter, but with the top one, you can make it longer so that you get your accurate measurement. We've aligned our protractor. We're extended out. Am I going to use the outside line or the outside numbers or the inside numbers? Outside numbers, right? And then I'm hitting 120. So am I acute, right, or obtuse?
Acute.
Acute. And then I want to measure it. So on my protractor, I line up right here. And I am between 50 and 60. Is that what you guys are getting as well? Let me use this one instead. It's hard. Well, it's hard on. Let me do it on paper because the projector is.
I got like 0.4.
Well, the projector is not.
Because you put the protractor on the side, right? Right in the of the curve of the angle.
Yeah, I put the protractor right on. I put the dot
On that point.
on that point. And see, yeah, I'm getting 45. So you put your hole. There we go. That's what I was doing wrong. You put the hole
Oh, there it is, yeah.
right on the vertex, and then I had to, when I did it on the paper, I had to extend it out, and then it hits right at 45 degrees. So see what I mean though, how much of a difference it makes if it's not lined up in exactly the right spot? It can make a huge difference. Vertical angles share the same vertex, bounded by the same pair of lines, and are opposite of each other. So basically what that says is if I draw two lines that intersect, right? They make four angles with one vertex. the angles that are across from each other are vertical. So in this case, the red angles would be vertical, but these angles are also vertical. So these would be vertical as well. So you have two sets of vertical angles when you intersect two lines. And it's just the ones that are opposite of each other. Okay. Congruent angles are angles that have the same measure. So all 40-degree angles are congruent to each other. Complementary angles add up to 90 degrees, and they don't have to be touching. You can have touching angles. So you could have like a right angle that was split into two other angles that add up to 90, like that. Yes. Sure. Right, so they could be touching and make a 90-degree angle, or you could just have two angles over here and like one over here, and let's say this one is 40 and this one is 50. Those add up to 90 degrees. They're still complementary even though they're not connected. Okay. So you could have two situations with that. And then supplementary angles add up to 180. Now, the way I came up with to remember which is which, if someone compliments you, they are right. Compliments, complementary. 90 degrees is right. So if someone compliments you, they are right. Hopefully that'll help you remember. Supplementary angles can be like complementary angles in that you can have two angles attached to one another that make up a 180-degree angle. Or you can have just two angles out in the world that make up 180 degrees. So if that was like 150 and this was 30, they would add up 20. So they would be supplementary. Adjacent angles are angles that share a common ray and a common vertex, so they're right next to each other. So, like that. This angle is adjacent to this angle. That didn't turn out right. This angle is adjacent to this angle. So basically they're angles that are stuck together. A linear pair are two supplementary adjacent angles formed by two intersecting lines. So if I take two lines and I intersect them, okay, and I number all the angles, angle 1 and angle 2 form a linear pair. They make they are supplementary, they make a straight line. So are angle 2 and angle 3. Angle 3 and angle 4 also make a linear pair. And then angle 1 and angle 4. So whenever you have the two intersecting lines, you get 4 sets of linear pairs. Does that make sense? So any two angles that make a straight line make a linear pair. And then an angle bisector is a ray in the inside of an angle that divides the angle into two congruent angles. Well, that just means it cuts the angle in half. So if I have some angle, any angle, and I take a ray and I cut that angle in half, this angle is the same size as this angle, then that's a bisector. Okay, angle addition postulate. So it looks like this. We have some angle A, B, C. Okay? And if I put D somewhere inside, and I make a ray, this tells me if I call this angle angle 1, and I call this angle angle 2, and let's say I call the whole thing angle 3. Okay. Rather than the letters, hopefully it'll make it a little bit. It's telling me that angle 1 plus angle 2 will equal angle 3. That's the postulate. The postulate is if I have an angle and I draw some ray in the middle of it, the two angles it makes will add up to the first angle that you had originally. And that's why it's a postulate, because it sort of makes sense if you think about it in terms of if your angle was a piece of pie and you cut your piece of pie into 2 pieces of pie, those 2 pieces of pie would equal the original piece, right? So it's one of those postulates. An angle has exactly one bisector. There's only one line here that I could put in, like line D, that would make angle 1 and angle 2 equal to each other. If I move it over even 1 degree, the measures aren't equal anymore. And then 2 angles that form a linear pair are supplementary. Well, the definition of a linear pair was that you had supplementary angles. So this goes with that. Now, the linear pair theorem, which has been proven, is that if you have linear pair, it equals 180 degrees. They had to prove that. But a straight line, a linear pair makes a straight line, and a straight line is 180 degrees. So we're good? And then the vertical angle theorem is that if 2 angles are vertical angles, they're congruent. And I want to do a picture for this because what we have, there's a reason I used the markings that I used last time. Vertical angles are the angles across from each other. To symbolize if angles are congruent or not, it changes the number of loops we put in here. So if I put 1 loop there, I put 1 loop here, this tells me that these 2 angles have the same measure because there's just 1 single loop. And then if I put 2 loops here and 2 loops here, that tells me that these 2 angles have the same measure. So that's how you show in a picture that angles are equal. Yeah, Tisha.
So why did the up and down one have 1 in that side has 2?
Doesn't matter. I could have done 2 on the up and down and 1 on the side. It just indicates that because these have the same number of loops, they're equal. And if there was, if we do, like when we get into shapes later with angles in them, and you know, we'll have like triangles. So like one corner would have 1 loop, another corner could have 2, and then the third corner could have 3, and so on and so forth. Yes.
Which definition is that for?
This is for vertical angle theorem. So just so you know, when you see pictures of angles that have the same number of loops in them, that's telling you that those angles are congruent. That's the picture representation. The on paper representation is when we make that symbol for congruent. So like if I called this angle 1 and I called that angle 2, I would say angle 1 is congruent to angle 2, like that. So by writing it out mathematically, we use the symbol for congruent. I didn't write that very well. Let me make that prettier for you. Angle 1 is congruent to angle 2. There, that's better. So writing it out mathematically, you use the symbol for congruent. If you're drawing a picture, you put the same number of loops in the angles.
Why is there 2?
Complements add up to 90. So we want to find 90 degrees, and supplements add up to 180. So the complement of 35 is going to be 90 minus 35. So that's going to be 55. That is the complement. The supplement of 35 is going to be 180 minus 35. So that is going to be 145 degrees. Complement, supplement. Yeah, well, if you're asked just to find the complement, you'd only have one answer, or if you were asked just to find the supplement, but we were asked to find both. Now, there are compound ones that, I forgot to give you guys an example of, so we'll just do it underneath. If you find the complement of the supplement of 120, let's see. Okay, when this happens, it's fine. This one said the complement and, this one says the complement of. There's a difference there. And tells me two answers. This is one answer. So what I have to do is I start with the second half. So the supplement of 120 is 180 minus 120. So that's going to be 60. So this portion is 60. And then I want to find the complement of that. So then I'll come over here and I'll do 90 minus 60. And so my final answer is going to be that 30 degrees. So whenever you see a compound one like this, so it can either say complement of the supplement or it might say supplement of the complement. You do this part first and then subtract whatever answer you get from here. Vertical angles to find y, because these two angles are going to be the same, so y is 123. And then to find x, I have a linear pair. A linear pair is added to 180. So x will be 57 degrees. Is everything